Hello, as Sami said, welcome. I know it's a Saturday morning and you could have done any other happy thing, but yeah, so today we're going to talk about Thorin.js, real-world framework for Node.js, and its capabilities and how it can actually help you develop a production-ready application. So I'm going to start with a couple of things about myself. My name is Adrian Punta. I am the CTO of Unlock, a cybersecurity company founded in 2014. I'm also a Node.js enthusiast. I've been working with Node ever since its first release back in 2010. And ever since, I've worked on a couple of projects with it. One of which is an online multiplayer real-time strategy game built with Node, Socket.io, and it has multiplayer capabilities, a few AI components. My next project was an ad bidding platform where we mostly specialized on kind of processing data and requests and events from various sources. The next project was a social platform where it had a REST-like API backend, after which we've added some WebSocket functionality. The next project was also a mobile backend where its main features were REST API endpoint again and a few WebSocket implementation, usage, and chat functionality. And finally, we've reached working with Unlock. We've started working in 2013 in December on it, and ever since we've kept on going. Unlock spawned two other projects that are mostly developer-oriented, which I'm going to talk a bit later, called sconfig and loglet. Okay, so why are we here and who we are? As I said, I'm part of Unlock Systems, which is a passwordless authentication solution. Its main focus is on it's on passwordless authentication with additional transaction authorization actions and personal encryption keys. Now, this part of the personal encryption keys part is a bit important because based on that functionality, sconfig and loglet was spawned. And as I said, I'm going to talk a bit about them. We're going to start with sconfig, which is a encrypted application configuration storage. So if any of you ever went with an application in production mode, you know that you need some kind of mechanism to store your access tokens, secret keys, connection strings, and so on and so forth. So sconfig can actually help you in this direction. It also has a built-in Thorin-friendly discovery system, which helps when you're developing applications in a microservice-oriented way. And of course, it has built-in firewall and access management support so that you know all the time that only your servers based on your IPs can access the configuration file, so that even though somehow at some point your sconfig access token is leaked, the data is still not vulnerable. The final project that we've launched is in beta right now, and it's essentially an encrypted centralized log management system where in a clustered environment where you have multiple nodes, multiple applications, you'd want to essentially hold all the logs that those applications generate, errors and associated data, into a single place where you can query them by time and date and essentially know whenever something is failing in your application. So based on this technology, it also gives you live stream application logs, so you can monitor in real time your application logs, and a couple of other features that you can find on loglet.io. Alright, so I want to talk about a bit about what we're going to actually talk about today. I'm going to start with who we are and what we do. What is Thorinjs? How can it help you? Then we're going to move a bit to the current stack that we're using, the one that powers Unlock iOS, Config.io, Unlock.io, and a couple of other side projects. After which I'm going to talk a bit about each and every single component that was written in Thorin.js to make your life easier. We're going to move on to some real-world use cases where if you want to build an application, you should know which plugin or which component you can use in order to focus on your actual code and not implementing other third-party services. This is essentially the technical overview that I'm going to present, and also the schedule is a bit flexible. We're going to have a few breaks over the presentation. This is the first part. So the second part, we're going to go to a live coding session where we're going to start with a traditional to-do application to see how the core functionality of Thorin is used, and the next period we're going to overclock the to-do application, add some nifty features that you wouldn't add normally because it's a to-do app, but in some real-world applications you actually want to add to bind other components in such a way that it allows your application to scale horizontally and your code to be maintainable. And finally, we're going to have a session of QA and conclusions where you can ask me essentially anything. Okay, so I'm going to start with the lessons that we've learned during our development period of 3 years or so. The main issue that we had is, at first we thought about having one module to rule them all. So basically we started with a framework called Crux, where we were thinking to add all these components, a server component, and then a logging component, and then the database component, all this functionality to have it in a single component, in a single module, sorry, and then use that module in all of our projects. At first it was a nice solution to our problems because back then microservices weren't mainstream, so we wanted to focus on a single application and having that code ready to ship out, which in turn made us work in a monolithic architecture, essentially having a large application that does everything, and from the API to the view layer to database and workers and all that chunked in a single application. In terms, when we started this, we started a project, and then we figured out, okay, we need to create a separate project that does a couple of things, and then we needed a way to kind of like share functionality between the two. For example, the model layer where we had all our SQL models. In turns, it brought us to duplicate a lot of our code, and things started escalating from there, and we had to do some bad hacks. And yeah, so the next bad thing that we did was having some kind of a limited dependency injection, where all the components that were inside the framework were essentially accessible from only parts of the application and not from anywhere. So at first it was a good idea, but then we said, okay, we have to change this because we need to access everything from everywhere. And finally, maybe the greatest thing that we did was tie the actual resources and data, so arrays of entities and so on and so forth, to actual views. So, for example, whenever anybody goes to the applications page, applications were queried and then displayed within a view using a templating engine. At first it sounded as a good idea, but then we had some problems with it, because then we wanted the data that was available in the views be available somewhere else. So that it was a problem there. Yeah, so that was our past experience with a few projects and a few stacks that we had. Our current stack is we're using React, Redux, Less, and Webpack on the front end. Redux is a little wrapper that would be created above Redux to help facilitate the communication between Thorin.js, the back end, and the front end single page app. On our back end layer, we have Node.js plus Thorinjs, Process Manager 2, and essentially Nginx as a reverse proxy. If you haven't heard of PM2, it's very nice. It's a process manager that helps keep your application alive, and it offers some nice overview of your processes and so on. At the storage level, we use MySQL and MariaDB plus Elasticsearch for NoSQL, and we also use Redis as our key value store and as our publishing, publish subscribe server. Now our views on the current projects that we have shifted from monolithic approaches to microservice oriented approaches, where you have to kind of like divide your whole application into smaller, more maintainable bits. So a microservice is a part that does one thing and it does it good, and it does it very well, so that you have multiple parts of different things where you can easily scale up based on single requirements. So for example, if you can have 10 API applications and only one mailer application, because you're most likely not going to send 1,000 emails a second, so you're going to send maybe 10. You don't need 1,000 mailer. You don't need 10 mailer applications online. Just need maybe one. So this is in terms of the microservice-oriented view. We also shifted to a more stateless approach on applications. So our applications are essentially stateless. What does that mean? It means that we never store any kind of request-specific data inside each and every single application. So for example, we don't store sessions inside a Node app because we want to treat our processes like cattle. So essentially you start with 5 and then you add an auto-scaling mechanism so that when your traffic spikes you can go back to 10, and then when the traffic decreases you can go back to 5 again. So in a stateful application you would lose data, right? But in a stateless application, every single node is irrelevant because no actual data is stored on it besides the actual Node.js application. And finally, my very own favorite, it's called Keep It Simple Silly. I'm not going to use the other word, but still, the main idea is try not to overcomplicate and not overthink things. If you have a view of how it should be done, do it. If it works for you, if it suits you, just do it, make it simple, divide it into smaller bits of code, and so that it just works for you. Now, a bit about Thorinjs and what it actually is. As I said, it's a Node.js framework built on top of different tested frameworks so that it allows you to build rapid, scalable, real-world applications. So at its core, Thorin is a stack of functionality that you can use, but its main power stands in its components. So Thorin is kind of like the chassis of the framework, and then you have different components that literally plug and play. You have different bits of the application that register inside the Thorin application, and it just works with your application. So it's essentially designed with usability and microservices in mind. That means that As I said before, it works very well in a microservice architecture where you have, again, bits and pieces of your larger application. It does singular and specific actions. Finally, it allows the developer to focus on the actual product, their app to work, and instead of Googling and trying how to make X and Y work, because Thorin plugins and components were designed specifically to get this out of your way. Okay, so why Thorin? Why not use any other framework that is out there? Mainly because it's powerful. It has a powerful and extendable core. So all Thorin's core components and core functionality, you can extend them. You can add. You cannot remove, but you can add functionality to it. It has every single component that is written for Thorin has a simple integration with other services. So, for example, you have your database layer, and you want to use, well, Thorin uses, for example, SQLize, which is a tested and proven ORM solution for MySQL and MariaDB and Postgres. But the downside is that you have to work a lot to just make your application work with the models that your application will have. So this is all abstracted away by Thorin, so that you can again focus on your components and building your application instead of focusing on making it work and boot up. Also, all the components that integrate with Thorin were designed to handle a specific use case where you don't have to actually reinvent the wheel. And in some cases, there are a few ways of implementing one thing, and we try to implement that thing correctly so that you can use it. And for example, you don't want a junior developer to handle passwords and how to store them in an application. You want because chances are that developer is not going to know about different mechanisms of storing the password. So there's a plugin for that, and essentially we try to make a plugin for anything. As I said, it's built on top of other tested frameworks. The main frameworks that we use are Express.js for the transport layer, for the HTTP transport layer. It's a tested framework. It works very well. It's highly performant. We didn't want to reinvent the wheel. We just want to make it simple to the end developer to actually create applications. And finally, it allows you to focus on functionality and not integrating with other services. As I said, when you start up a new project, essentially you start with requiring one module, and then you maybe go on for, let's say, 2 hours to create some of your stuff, and then you go like, okay, so how do I do this? Well, I don't know. Okay, let's Google how to do that, and then you waste a lot of time into Googling how to do it. So that's a bit of a overview of how Thorin and why I chose Thorin. And out of the box, simply just the Thorin framework gives you configuration loading. So essentially, you can have your project's configuration, and then you have environment-specific configuration. Everything is abstracted away from you. You just place your configuration in a JavaScript file, and Thorin loads it for you. It has a global logger, and it allows you to namespace your loggings. So you have a global log.debug, for example, and then you can create your own logger for your mailing component, so that all the logs that logger outputs will have a specific tag, and you can basically search on that tag. It also offers input sanitization and conversion. So essentially, when you build an application, that application will most likely work with input data, So in the web world, input data is quite important because in some cases it can corrupt your real data if you don't sanitize it correctly, and if you don't convert it from, let's say, strings to objects and so on and so forth. It can crash your application. So sanitizers is an important part of any kind of application, and most other language frameworks have this built in. And if you look in the Node.js community, you see bits of modules that are specific, and then you see bits of sanitizers here and there, but most of them don't offer you out of the box everything. So in Thorin you get a lot of sanitizers. You get string sanitizers. For example, you have an IP sanitizer where you check whether a string is an IP, it's a valid IP, and whether that IP is within a range and so on. So this part is covered by Thorin. The application is also environment aware. So when you boot up the application, Thorin scans information about the environment, about arguments, Node.js arguments, about environment variables, and so on and so forth. So you have all this. Thorin does all this for you. In terms of routing, it has a centralized dispatcher for request handling. So you don't have to actually think about how to organize routes and how to essentially pack everything up so that your application boots. And if you do it in one application, in one project, one way, you could probably do it another way in another project, and so on and so forth. Thorin tries to standardize all this so that when you're working on one Thorin project, you know that that standard applies to the other project, and so on and so forth. It also has action encapsulation, definition, and specification. That means that in traditional web applications, you have the request object and you have the response object, right? So the request object has information about the incoming request, IP headers, and so on. The response has information about the things that you're going to send back to the client. And this action actually abstracts away all this. Well, the intent does that. I missed it up a bit. The action is actually the definition of how you define routes inside a Thorin application. I'm going to come back to that. The intent is the one that basically abstracts away the request and response and offers you information, a single input object of data coming in to your application, and it will offer a single object to the output of the request. You're going to see this later. It's a bit hard to explain, but if you see it in action, it's going to be a lot easier to understand. And as any kind of framework, it offers authorization and middleware support, where you can plug and play different middlewares in the application. Alright, so in terms of, I talked a bit about the core of Thorin, the main functionality that is inside the core module, the Thorin module. And these are a couple of things that you should know when using Thorin. So first we have transports. In essence, the transport in Thorin is a mechanism, is a highway that gets data from one source and tries to make that data make it in such a way that Thorin understands it. So it unifies the input data. So for example, we have an HTTP transport where it handles HTTP requests, and we have a WebSocket transport when it handles WebSocket requests and WebSocket events. So it standardizes everything, and it offers you a single intent that contains all the information of the request. Stores are the ones that hold, so they try to abstract away the storage layer of your application. If you have, for example, you want to create a REST application, CRUD application, you can use the SQL storage where it handles all the model loading and the database creation and so on. You can also use the Redis store, which abstracts away various functionalities of the Redis module. So, for example, you can get and set and hset anything with that wrapper. The sanitizers that I talked earlier are the bits and pieces are functions that check whether the input data is some kind of string or number and so on and so forth. Libraries are essentially just defined in Thorin. Those are the ones that you use in your application. So, for example, if I want to make a to-do application and I want to have some kind of functionality that checks if a to-do is for today or tomorrow, for example. You can create a library, so essentially it's a service in other languages, but in Thorin it's a library, a bit of function that you can use in different parts of your application, so that you just don't duplicate your code. And finally, plugins are kind of components that extend the basic building blocks, so they can work with transport, stores, sanitizers, and libraries, and essentially extend them. Now, in terms of things that you're going to be working with Thorin are actions, which, as I said, are in different frameworks. They're called routes, but in Thorin, I wanted to call them actions because I wanted to make Thorin easily integrate with a React application that uses Redux or the Flux pattern, where you essentially have types, action types that are happening, and then those types have payload. So, for example, you want to log in a user, the type would be user.login, and the payload would be the actual information of the user. So, in a normal REST application, you would have to do a POST request to an endpoint, and then that endpoint would return you a JSON or something. In Thorin, all the actions have a /dispatch handler. So, for example, in a normal REST application, you would have, let's say you want to list all your to-dos, so you would have /to-do, and then /to-do/id, and then delete /to-do/id, and so on and so forth. That means that when you start a new React project, the first thing you got to think about, if you're using a RESTful API, is, okay, I have to convert my types into URLs, right? So even though I have a todos.find action on my front-end app, I need to map that action to a URL that the backend understands, right? So get /todos, right? So I wanted to kind of abstract away this because in essence it leads to code duplication, and it leads to questions like, okay, should it be a POST request, should it be a GET request, what would be the URL, and so on and so forth. So when using Thorin, you migrate from traditional RESTful APIs to a more action-based API. This works very well with applications that use the Flux pattern. It doesn't mean that you're limited to this, so you can have aliases for your actions. So back in our example, you have a to-do.find action, and you can say, okay, this action can be called also in get/actions, or it can also be called in get/todos/my-todos, for example. So you can alias all your actions. And even though you have one action and 3 aliases, that code is going to be called whenever either that action or a request coming from 2 aliases is going to be made. So essentially, don't duplicate your code.